Hello, my name is Rich Howard, owner of Architectural Builder Supply, and this video is to bring you a closer look at the Trine number EN950. This is an electric strike. This is a 24 volt AC electric strike in a 10B finish and a right hand. So we're going to dive into what is the EN series, specifically what's the EN950, why did they ask for 24 volt AC, why is it handed, and the finish. And we'll start this video with a visual tour of the equipment itself. And I can tell you that I have been buying Trine strikes for 30 years or so. Trine, I think initially, at least by me, certainly, was, for me it was known because of what we stocked as a economy grade strike. You know, the spring controlled, solenoid driven strikes that you would see in wood frames in typical 3 flats. Low end strikes, low end because they're dirt cheap, $28 for an electric strike. You know, that sort of stuff. And it just turns out, though, that they have a commercial line that I have really become quite partial to because it's never let me down. That's, if you know what I mean. You get burned by an electric strike, figuratively burned. You're not so quick to go back to using that brand anymore. And I have had unfortunate circumstances with one manufacturer's strikes, and I just tend not to use them, and I attempt to dissuade people from using them because I've had, you know, measurable failures with the material. You know, you know, we all have our own experience with Trine. I have had flawless experience, rock solid, simple, no nonsense. The stuff just works, and does so flawlessly. Okay, so this is an EN950. This has the strike. It has this funny looking plate, which we're going to go over as well, which can be thought of, I suppose, it's part number 13 as a perhaps support plate. We'll go over the installation instructions. We won't go so far as to rehand the unit, which I've done in the past, but these solenoids are required to be ordered as handed, and it's because of the way that they're designed. This video is not going to talk about how to rehand these, although you can, most definitely. This would be, of course, considered an armor front sort of scenario, what you're going to have on this. This support bracket that's going to be behind here. Pretty sure that's where that's going to end up being. Okay, so visual tour. We've got a strike plate that if it didn't have this very long faceplate, you wouldn't think too much else about it. But it has this long faceplate for a reason. This will fit into the preparation of a Fulguratum 310-2, which means that it is a 9-inch tall strike that is about 1 3/8 inches wide. Okay, so if you are removing one of those strikes and you want one to go back into the same hole, it might be a fire-rated frame. You can't make any modifications to it. This could be a very good contender for that. Also, in with the packaging, just to finish up what's in the packaging, they're going to give us these shims, and these shims, there are some plates here and some screws. These shims can permit you to get inside the keeper so that you can narrow the distance inside the keeper so that you can more finely tune your installation of where your latch bolt needs to fit, because you don't want the whole latch going in. You want the dead latching part to be retracted to rest on the lip, or on those support shims, but the fact of the matter is you very likely are going to need to pad that in. So they provide you with 3 of these shims. The finish screws, obviously, for attaching it. These are machine screws. This client, I know, is going to a wood frame. In fact, the error was mine because I did not specify wood screws for this, so it would be certainly natural for the factory to conclude standard packaging of template machine screws, or TMS. But I did, of course, round up some complementary wood screws, complementary finish wood screws for this, and we'll toss those into the packaging for the client. You're also going to get your wire connectors, okay? Rich Howard from Architectural Builders. May I ask you a question on an EN950? So in the package, I've got my 2 wire connectors, but there's a roll pin in there. Why is that roll pin in there? Yeah. I've reversed the strikes in the past, and I suspected it was there for that purpose, and I wanted to be absolutely sure. And then the 2 very small screws that are inside of that packaging as well, incredibly small. You know, whatever. Yeah, I was going to say 440, they look like. Yeah. Yeah, I thought to myself, well, the only place that's going to go, and if I don't reverse my handing, I have no chance of losing it, but it's nice to have it. Okay. Well, thank you very much for taking my call, and that was everything I needed to know. Thank you, sir. Bye-bye. Bye-bye. So that experience of speaking to Trine, every time I call there, I either get the gentleman on the phone and he answers my question perfectly, professionally, promptly, happily, or I leave a message, then he calls me back 10 minutes later. That sort of scenario. So if you were to reverse the hand, this roll pin is probably going to come into play because you're going to use it in the process of reversing the hand, but order it the right hand. The 2 very small screws, the gentleman did not, he says, I don't know why those are in there. And it could be because there is a very small screw that you use to hold the solenoid on. So if you were to reverse the handing and lose one of those screws, you've got them. I do not encourage you to willingly or voluntarily work to rehand these. Order it the right hand, but you can rehand them in the field. I found that I had a small learning curve doing it. And once I did it, you go from can't do it to frustration learning how to do it to expert level. So I graduated through that process. But if you don't reverse anything, you might not even use these wire connectors. These 2 screws are here. They're just, if you were going to need stainless mounting screws, for the face here, which you wouldn't. Because of the finish, they've included our screws. So that package is not going to come into direct play immediately, in my opinion. Now, let's take a look. Oh, are some supporting documents. This is your dimensional drawing. This is your installation instructions. Those are obviously going to come with your packaging, and we're going to place those on the side, and we're going to go over all the steps. This is, of course, your armor. It's like a reverse armor front. This is a support plate that you will apply behind here, and you should definitely apply this. I would not use it without. Now, what this client is doing in particular, before we get to the part numbers, to the supporting documents, this client has an outside gate, 2 of them, in fact. One of them will be on electric control. The client has inherited these doors that have incredibly close center to center of the lock hole and what would be a deadbolt hole. Very close. I forget the dimension. They're so close that there may be as much of 1/8 of an inch between the 2 locks. The client can't make any changes to that. They're an unusual thickness. It's already drilled. And what we're doing is what the client's going to do is, from the top down to the center is 4.5 inch. Okay, this client has a situation where the deadbolt is so close that there was no way to install an electric strike outdoor rated. Okay, so the strike, the client came to me and said, I need some mechanical locks. Oh, I want to do an electric strike. I was told to use this. Coincidentally, the one manufacturer that I try to steer away from, they say that it's rated for exterior use, and I looked up the documentation and I found no such reference to exterior use. No such reference for that. Well, they said it should be okay, and I thought to myself, that does not sound like a professional tech support individual for a major manufacturer of electric strikes. It seemed strange to even hear that. Electricity and water don't go together. I know that I like to rely on Trine for exterior strikes because I've used them in the past with 100% success. Immediately steered the client to Trine. Here's the problem. There was not an exterior rated electric strike that was small enough to not interfere with where the deadbolt was going to go, a smaller version. So I decided, well, if we can't go smaller, let's go bigger. So what this client's going to do is install their cylindrical lock here. Then we're going to drill, the client's going to actually prep the edge of the plate to become the strike for his deadbolt. Okay, so that's going to be a real neat way to make all this work. They'll just have to get in there, though, and prep all that. And I would certainly remove the entire faceplate from the mechanism, from the solenoid part. I wouldn't want to run a lot of heat, building up any sort of residual, energy with that solenoid. And speaking of the solenoid, earlier today, one just passed my desk, a replacement solenoid for this strike. They're really inexpensive in the sense that, a replacement solenoid is easy to get your hands on. Okay. Here's the label on the back of the strike. Now, why did the client want AC? Well, you've got AC and DC. Okay. Without getting into a description of the difference between the two types of AC and of voltage, there is DC, which is typical low voltage, most common in commercial builders hardware, electrified commercial builder and residential builders hardware. But then there's AC as well. If you've ever heard a strike buzz, that's AC. AC buzzes, DC just doesn't. There's no sound. So we had the conversation. How's the pizza guy going to know that the gate's unlatched if it's DC? He won't hear a buzz. You know what? Make it AC. And plus also the intercom system they had was supplying AC voltage. Because the intercom people probably realized, yes, people want to hear an audible buzzing, and AC voltage provides that. I don't remember the science behind why an AC voltage is going to buzz. It would be an easy search online to cure your satisfaction as to why that's the case. I just don't recall. So that's why this client's using this funny long strike in an AC voltage. Why this 10B? This is just a powder coat, because they're doing oil rub bronze. That stack of Schlage locks there are for this customer. The AL series lever with the B250 slam lock on the back gate and the B560 on this one. And it's a right hand. So we ordered this handed, and the one mistake I made is I didn't tell them wood screws. We ordered it right-handed because it's a right-hand gate, and I didn't want the client I insisted on knowing the hand because I've reversed these, and it's not for the faint of heart. It's not for the homeowner to do this. And a person who installs gates is not going to be interested in trying to learn how to rehand that. And it took me, someone who's done it, who's been in this business for decades, it took me a couple of stares at it before I understood how it worked. There's a shifter or a slider plate that's involved that you have to get put in place, and it's one of those situations where your fingers are oily and you really need one more finger inside of there to hold it retracted, get the slider in, push the pin in through the spring, the whole 9 yards. And it works flawlessly, but it was required a bit of a contortion to make that happen. Just my experience. If I did it all the time, I would probably do it blindfolded quite easily. Now, let's dive into the supporting documents that are linked to down below this video. Okay, so this Trine EN950 item that we're looking at, there are supporting documents down below. First of all, there is a strike selector that's here, and it's just a simple one-page document to help you, and assist the selection of the proper strike. Okay, so your lock type listed across the top, that's where you need to start, because the latch assembly of your lock set will determine the strike type that is permissible for you to use. Okay, so they're obviously associating a letter with the possible strikes that you can use. You have to be careful with mortise locks in the sense that the deadlocking feature can be above the latch bolt or below the latch bolt. And the reason that's important is they're saying your A and B options with B and the asterisk what they're saying is when you are selecting a strike to use, you need to be mindful that you're going to have an area that the deadlocking tab can rest against. Okay, so here in the A strike, or in the B strike as well, the flat area above and below the cutout would be the appropriate area for the deadlocking tab to rest against. And same with aluminum storefront as well. Okay, there are different latch types presented here. So the cylindrical lock generally will have a latch throw of 1/2 inch, meaning the length of the latch is 1/2 inch. They can be longer though. They can be 3/4 inch. So, but 1/2 inch is standard, but you have to be sure of what it is first. Mortise locks, I think, exclusively have 3/4 inch length latch bolts. Okay. Now, the latch bolt type on a mortise exit device will emulate a standard mortise lock. So nothing new there, but the latch on a rim exit device is wholly different altogether. Okay, so the A strike that Trine has, the 4100, is going to work for almost all of these, but not the rim device, because the rim device has a substantially different latch bolt in design. So you'll be looking at different options for those strikes. Okay, the strike that we're using, what put us on the path of needing a particular strike, is the fact that we were dealing with something that is exterior rated. Okay, so exterior rated is where we knew we had to be, and that dictated from the group with which we could select from, and I simply selected a strike from that group that would be compatible with the standard 1/2 inch cylindrical lock latch that we were dealing with. Okay, so the 4100 is going to work with lots of applications. Okay, if you get to exterior rated, you're going to be able to look at these other series, very possibly. The keepers that you're going to run into for a rim exit device, an exterior rated with this would be this C type. The other rim exit device would be the D and the E type, and these will work for panic devices. So unless you have an exit device that features a Pullman latch, which is what this is called, this curved style latch, the A strike is going to work for your application. Okay, but then from there you can deviate and tweak what you might possibly use. In the realm of a cylindrical lock, you obviously have many additional choices listed primarily here, where you can have some control over the size of the strike that you're going to prep the frame for. Okay, then down below in their columns will show the type of frames that these can be used on. So the select a strike model is or document is handy, because it will allow you to
get an overview of what you're dealing with. Now, the next document we have are installation instructions. Let's skip over that and go to the catalog cut sheet, which is here for the EN950. And again, you would buy this if you have a Folger Atom 310-2. Okay, so a 310-2 is a strike with a very long faceplate. And there are so many of the Folger Atom 310-2 out there that Trine literally makes a strike. That's an EN series strike, but with this modified faceplate to fill that cover. If you need to replace the Folger Atom 310-2 and you want to use something else, this would be a strike for that. We selected it for the very different reason I had mentioned earlier, because we wanted to force a deadbolt to fit up in this unoccupied faceplate area. Okay, for new or replacement installations in wood or metal jams, used with mortise exit devices, mortise locks without deadbolts, and cylindrical locks up to a 7/8 throw, based on an 1/8 of an inch door gap. So, a couple of things there. No deadbolts in your in mortise locks, because this doesn't have any prep for a deadbolt. What I really mean to say is, in our strike selector, none of these have a deadbolt. Trine does not offer, apparently on this document, a strike that will keep a deadbolt as well. Now, having said that, it would very likely, and we can take a closer look, if this faceplate was completely cut out, you could probably fit the deadbolt and latch both within this keeper. And I think that is certainly worth investigating. Yeah, I think right. So this 4100 DBDL strike, which they don't have listed there at all on their selected strike, that document must be a little bit older. So you can definitely handle a lock, a latch, and a deadbolt in a single strike from Trine. 2 independently activated latches. So the point of the matter is, if you have a deadbolt on a mortise lock, you'd be able to ultimately make that work. So this is for mortise locks without deadbolts. They have a solution if you have a deadbolt. This also tells us something very important. Deadbolts and cylindrical lock sets with up to 7/8 throw, up to a 7/8 throw. That means that the length of the latch bolt, okay, the length of the latch bolt cannot exceed 7/8. I'm not aware of one that will. I believe there is a latch for some lock that is a 1 inch, but my memory is very foggy on that. The point of the matter is, the length of the latch bolt cannot exceed the depth of the keeper. So as long as your latch isn't longer than 7/8, this will work. So that means cylindrical locks, even with a 3/4 inch throw cylindrical lock, and because you will have requirements for, when you look at the fire tag on your steel or wood door, it will say min latch throw. It generally says 1/2 inch. It can also say 3/4 inch. Okay, you have to check and see what it says. In pairs of doors, it'll be very common to have a 3/4 inch minimum latch throw required, because the latch has to fully extend into the keeper to prevent it from binding. It's a rookie mistake to sell a strike that will accept only a 1/2 inch keeper, a 1/2 inch latch throw, but you've got a 3/4 keeper. And your client will call and say, you know, the strike works sometimes, but not all the time. That's because there's some mechanical binding. So when you're doing an electric strike, you have to also then say, great, what's my latch throw, and will the strike I'm selecting accept the projection of my latch throw? This will work for, you know, the other reason the EN950 worked is because it worked for every possible lock that would have been in play because there's no deadbolt and there is no problem with the latch throw. So that's our cut sheet there. Then we can move on to our detail on the frame prep. Let's talk about that now, which will give you the dimensional properties of what the strike is. And so this will show you this is not the frame prep. This is just the dimensional properties of the strike. So 9-inch tall faceplate, 1 3/8 wide. You can see the length of the face of the strike, 1 11/16, 3 3/4 tall. And that's really what you need to know for your frame preparation. And if you're comparing it against that 310-2, those are the dimensions you're looking for. 1 3/8, 9-inch, 3 3/4, 1 11/16. Okay. So then we get to the frame prep. Now it shows you what they want you to prep in the frame for your strike. Okay. You'll take note that they have a couple of deviations in terms of the prep in the frame and the actual dimensions. They may want a little bit of extra room in the width. That is 1/16 of an inch smaller because that strike probably hangs off the face of this a little bit, which or it actually probably rides over the back of this a little bit, would be my guess. So that's your frame preparation. If you are ordering a hollow metal frame or an aluminum frame for that matter, which I don't know about an aluminum frame, you're going to need a 2-inch wide face on that frame for that. Probably going to be looking at a different. You're probably not going to be using same kind of locks that we're talking about on aluminum doors, but a hollow metal frame is what you're looking at. Can you make this work on a wood frame? You can, but you've got to have, you're going to be starting out with, for sure, 10-quarter lumber. It's got to be, thick material to accept this type of strike. And strikes for wood frames are generally very different in design than other strikes. Okay, they do indicate that you can fit them on to wood frames, but again, be mindful of how much room you need for that. Okay, you might be looking to select a more petite strike in that regard. So that's your frame prep. Okay, now select a strike. Just cleaning up our tabs here to know what we've done and what we've not done. Now the installation instructions. So the way that these are laid out, okay, is this is page 1. What's over here is actually page 4. Okay. All right, now EN950, EN960 installation instructions. I want to hop back to the Trine website. I don't know what the difference is on the EN960. Okay, so the 960 clearly has this return leg here. Oh, I understand. So it is the unit that is used for the 310-2 3/4 cutout. So the 3/4 strike is a different Folger atom than the 310-2, and it's basically a dimensional property. The faceplate's going to hang back further. Okay, so what we start with here is identifying the parts that we have, and we're just working on this side of the page. The parts that we have are identified all in here. Should you want to take the strike apart to rehand it, it would be very useful to you to understand what they're calling, especially part number 2. Okay, the slider. I called it the shifter earlier. It's a slider because you will need to potentially modify that. Part number 11, that acts to keep everything in place, if I recall. Slider guard, sure. Slider guard, okay. Part 10, part 8 8 is the assembly pin, and 10 is the latch pivot pin. That 8 is the part that's included in that package that I don't really think you'd end up needing at all. I didn't. I just replaced the one that was there when I changed the hand in a prior video. You have those shim plates that I had mentioned earlier. You might very likely need those. I would expect that you will. You know, depending on the mechanical installation. You obviously have your keeper. What do they call that? It's the latch itself. Okay. Solenoid back here. Your armor front or your support bracket, part 13. They don't call that. Part 12 is what they're saying your support bracket is. So understanding the layout of what you're dealing with would be a great place to start with this. Okay. Now, you'll see its certifications. It is listed for UL10B, which is neutral pressure, UL294, UL1034, ANSI A156.5. So these are its certifications. Be mindful, it's not listed to UL10C, which is positive pressure. You might need to... could you bump into this strike in positive pressure? Yes, you could. This document does not indicate it's UL10C rated. Grade 1. Okay. Obviously, if you're doing a fire-rated door, you'll be doing a fail-secure strike. We're doing fail-secure here because this is a gate. It's normally going to be locked. We wouldn't want to power it at all times to lock it, which would be fail-safe. And you would not use a fail-safe strike ever on a fire-rated door. Voltages, as you can see, 12 or 24 AC, which is intermittent duty, which means you're going to power it only when you want to activate the strike. So the solenoid, therefore, is of intermittent rating because it's not going to be powered continuously. The DC strikes can be powered continuously if you want, intermittently or continuously. Okay. And then DC strikes are silent. They click. You'll hear a clicking sound if you listen for it, but they won't buzz. Okay. So that is the summary of page 1. Getting over to page 2 does spend all of its time teaching you how to rehand this strike. If you're going to need to rehand the strike, you're going to have to, you will definitely need to study this page thoroughly. Removing the pins, and the problem with that is the latch is under spring tension, and while it won't likely fly out on you, it's under spring tension. There is a spring inside of here that I don't see they're showing us. It's shown here, part number 9. And you can refer to a different video of mine on a Trine EN strike where I reverse the unit, so we won't do it here. Replacing the solenoid, should you need to do, is called out down here. You do need to remove, of course, the cover, these 2 very small screws, to get to the solenoid. Should you need to replace the solenoid, you can, is the point of the matter. So we won't talk anymore about how to rehand this. Different video. Wiring of the item, simple and straightforward. It's, it's simple and straightforward. AC, you don't have to worry about polarity, obviously. DC, you do. You'll know the solenoid rating because of how the wires are colored, and indeed, as I look at the strike on my desk, I do have a blue wire and then a black wire with a stripe, which happens to be a white stripe. Let's see. The position of the electric strike in the door jamb will be the same as a right-handed door and a left-handed door. For these installations, the electric strike position in the door jamb will be as shown. Okay, so what they're saying is the position of the strike for a right-hand inswing or a left-hand outswing is the same position. Yeah, sure. A right-hand inswing and what they're defining here really is they're saying the EN strike must be installed with the coil assembly up. And that is because the slider plate is gravity. It relies on some gravity to operate. In this position, the electric strike will be locked without power or locked with power. Before performing the handing feature, view the electric strike in the up position to determine if you even need to rehand anything, because the position of electric strike for a left-hand inswing and the position for the electric strike in a right-hand outswing, are considered the same installation. Although it's a little confusing the way they state this, a clear definition is here. The position of the electric strike in the door jamb will be the same for a left-hand reverse bevel door and a right-handed door. Because a left-hand reverse and a right-hand door to the electric strike are the same swing. So the point of the matter is, you may not need to if you happen to have a left-hand reverse and you ordered a right hand, well, you've got the correct strike, okay, because it's the same strike. The wire leads we've unintentionally already identified. Prepare your frame. Wire length, this is very helpful. You want to make sure that you observe this. You need thicker wire for a longer run because that increases the conductivity of the material, of the wire, allowing the same amount of push, so to speak, your voltage. Think of voltage as push to get through the wire to the specified length. Failure to observe this is going to give you the trouble I had mentioned earlier. And obviously the amount of push will change your required wiring diagram, your required wiring gauge, your wire gauge. Okay, 12 volts versus 24 volts. DC operation: to obtain an audible signal when a strike is energized, you can install a buzzer. For if you have a DC strike and you want it to buzz, you can add a buzzer, and they give you the two part numbers here for 12 for 24 volt. Okay. More conversation about prepping the frame. If you are running a rectifier, if you have a DC strike and you're powering it with AC power, you will need the rectifier. They show that buzzer being installed here and how it's wired in for your DC. Your 120 coming in, your power supply or transformer. Hitting the strike, you have your switch that is normally open. That means the circuit is not permitting current to flow. When that switch is momentarily closed or allowing power to flow, the buzzer will run, the strike will run. This is the same scenario when you are powering it with AC voltage. Okay, AC voltage, and you have a DC strike. You have to put a rectifier. A rectifier basically alters it clips the property, the wave of the electricity to permit it to be compatible with a DC environment. It's not DC voltage, but it alters the AC voltage so that at the end of the day, it's compatible. The rectifier can be positioned before or after the push button. That's true. That doesn't matter, because as long as it's As long as it is upstream between the strike and the transformer, it will work. The push button, likely doesn't care. When wiring the optional buzzer, polarity must be observed because it's DC. You've got the two ends of your battery. You got a plus end and a minus end because the electrons need to flow, and that's why there's polarity. Okay? Black is negative, red is positive. Same as a car. So that would technically be page 3. The last page 4 gives us some troubleshooting. And to look at our troubleshooting, door lock set is not secured by electric strike. Sure, check your mechanical installation. Make sure that your latch bolt projects properly into the cavity of the strike. We talked about the length of the latch bolt earlier. Or that you have some other mechanical problem like the latch spring is broken or missing. Suggested remedies. And when people say a strike doesn't work, the first thing I say is, well, you have to check the power. Do you have power? You'll have to use your voltmeter and make sure that you have power at every step. Is there power coming to the power supply or transformer? Is the proper power coming out of it? Okay. Is there power immediately at the strike when you activate it? And that's where, that's where those conversations need to start. So diagnosing a strike over the telephone, a strike problem, when we've not used a voltmeter is, it starts with we need a voltmeter to check that. Slider does not move when coil receives proper voltage. If you still have a problem, you're getting proper voltage, you might have a different electrical problem. Using an ohm meter, a multimeter will obviously read ohms or resistance. Verify that resistance of coils matches the chart on page 3. Page 3, I didn't see our ohm. Sure I did, right here. So you got to make sure that you're reading the proper ohms as well. If you have an ohm rating outside of what's listed here, then you likely have a problem with you would have a problem with the solenoid. There's some problem in the solenoid. There's something fused or shorted that you're getting like a much higher ohm rating, or an infinity maybe on the ohm rating. So you need to check that. Check your volts and your ohms. If you're ever in problem after volts, then check your ohms. Lock set is applying pressure to electric strike, preventing latch from releasing. That's called preload. This is the most common mechanical problem. You have to not have any preload, meaning your door is hinge bound. Like when you push the door in the closed position, it wants to naturally spring back open. That sort of problem must be rectified before you use an electric strike. Whether or not you're using a rectifier, the door must be mechanically sound before you attach hardware, and that would be what needs to be done. Check that the lock is not binding. Your weather stripping may be causing it to be bound. You may have installed the strike in the wrong place. It might be the wrong type. You might be engaging too much of the latch bolt into the cavity. Your deadlocking tab might be falling into the keeper as well. So you want to be mindful of that. So we've covered the installation instructions in a cursory perspective. If there's a particular question on this, reach out and we will be happy to diagnose this. Let's finish up this video on camera. Okay, now finishing up our video on the Trine EN950 strike. I did want to illustrate at the very end of this strike that we are indeed dealing with and I was about to demonstrate how the lock is in the locked position and how the slider works on gravity. And you'll note it's a right-hand strike that they have here, and it's AC. So when it's AC, you're certainly going to want it to be fail safe, meaning when there's no power, it's locked. When you energize it, you'll hear the buzz and it will open. Well, the strike that we have here is for a left-hand door or for a right-hand reverse. A left-hand door or a right-hand reverse, not a right hand. Now what I'm going to do is I'm going to check. I know that I ordered a right hand. What I'm driving at is this. That's locked. When I turn that upside down, you hear that click? When I turn it upside down to be a right hand, I'm now unlocked. That would be considered fail safe. It's AC voltage. I'm only going to power it intermittently. If it's a fail-safe lock, I have to power it in order to lock it. It's a gate. I want the gate locked. So they've marked it right hand, but it's not for a right hand lock. So I'm going to confirm that it isn't right hand reverse. And I'm looking at an email now, and if it's indeed a right hand, because I don't remember, this order is about 3 weeks old at this point, we're going to have to reverse the lock. Yeah, it's clearly a right hand. So in this video, we are certainly going to reverse the hand of this strike so that it works correctly, which means we have to swap the slider over. I was not planning on having to rehand this in this video, but we're going to, because I've got a right-hand gate. I'm not going to send this to the client and expect that they're going to hop into rehanding this. That's just not going to happen. So let's get set up here and reverse this strike. Okay, let's get on with the rehanding procedure here. Definitely needs to be a right hand. This has to be locked. This has to be locked. Okay. Definitely needs to be locked. You know, what do we do in this sort of case? We call the manufacturer and tell them it's wrong, or we just fix it. Yeah, we're just going to fix it. That's what we do. Okay. So let's get. I know that these. I recall that I have to get to the inside of this unit. And I believe this screw just holds on the solenoid. So I'm going to remove these two first. You definitely want proper fitting screwdrivers when you do this type of work. Okay, so that cover comes off. And that's our slide. That's what's responsible for this working in one orientation and not the other. And when the solenoid is energized, it's going to pull the slider up, which will then lock the unit. When the slider is down, it's unlocked. When you energize that, it's going to pull the slider up, and then it's going to lock the unit on us. Okay. Okay, so what they need us to do, we might need to pull the solenoid out. Let's take a look. Disassemble back cover and the solenoid of the left-hand configured EN strike. This is definitely left-hand. So disassemble the back cover, which we've done, and the solenoid. So let's take the solenoid out. Single screw holding that on. Thankfully, these screws are not exceptionally tight. Our solenoid is loose, and that will just come out. So replacing the solenoid is literally that easy. There's no moving parts on here, but when that field is there's no moving parts on here, but when that field is created, it will pull the slider up into the cavity. So I'm going to put that aside. Now, I know that we have to pull our pin out. They're saying disassemble the back cover and solenoid of the left-hand configured strike. Using the assembly pin, push the latch pivot pin out. Okay, so that's what that roll pin I think is for. Yeah, that is definitely what the roll pin is for. If you have to, basically it's a tool. This roll pin is a tool to use. Get that pulled out of the packaging there. Right, so you are going to, just like you would with a cylinder and a plug follower, using the assembly pin, push the latch pin pivot out. Which I'm just going to push on the latch pin, but I'm going to put it down on my desk here. And push that out. Well, I definitely have the latch pin out. That's our latch pin. I believe that's made of stainless steel. Definitely not. Piece of steel. Take the latch and spring and slider guard out of the frame. And because the next step literally says take the latch and spring and the slider out of the frame, using that roll pin is just allowing you to remove that latch pin, but it doesn't stay inside of there. It can't. Otherwise you won't get your equipment out. So I'm going to pull my roll pin out that I placed inside of there. And as I pull that out, I'm definitely going to, I'm just going to pull the latch pin out. Well, not the latch pin, the roll pin that I installed in there. I'm going to keep my finger on the keeper because I know something's going to jump. So it says take the latch and spring and slider guard out of frame. That spring is down there. I'm going to take the latch out. The spring and the slider guard out of the frame. That's the slider guard. I'm going to pull that out. Okay. Okay, so what we originally had was this dimple as called out in the installation instructions. That was the fail, that's called the fail safe slider position. Dimple shows fail safe slider position. Okay, so when that was pointed towards the top, we were definitely getting a fail-safe operation. So, and it was oriented this way. So logically, we're going to need to flip that over. Okay. That's the dimple right there. That one. Okay. Now, one thing that you can do immediately is this roll pin. It does make life a lot easier when you're reversing it. You can do it without, but I wouldn't recommend it. In the installation instructions here, they show how to assemble the unit back together. You just study how the spring is, the long leg towards the bottom. And what I would suggest that you do is hold the strike, the latch itself in your hand and literally place the spring inside and compress it in place. Like I've just pushed it in there. Now you're going to use that roll pin and slide that roll pin down in there and keep the spring captive. I've got it poking through here. Now what's going to happen now is after I reposition my slider and my slider guard, I'm going to want to be able to put this all back into the cavity, into the keeper area, without trying to fit the strike and the latch and the spring in there at one time. So the tool is necessary as a placeholder. Now when you drive the latch pin out, if you push that in far enough, you can remove the whole assembly with the spring already captive. But I don't think that's really going to be necessary, because you can assemble it just as we just did. So the dimple was pointed towards the top in my right hand orientation. Okay, that was fail safe. So fail secure, I'm thinking I've got to just flip it over. And I've got to tell you, I'm not super enthralled with the installation instructions. They seem a bit esoteric. But when you look at the picture in step 3, it is literally showing you that you need to stack it like this. Okay, now I'm going to put the slider guard back in the way that they're showing, and these little prongs are going to need to sit in these rectangular holes. Okay, so I'm going to place that slider guard back in. I'm going to make sure that my slider guard has the prongs projecting down into the holes. And I'm going to leave it sit just like that. Just like they show it. Okay? Because that's how they show it. So again, we have that position right where it's shown. Now what I suspect is, the way that this works, is that these ridges right here and here, okay, the keeper obviously needs to rotate. And in the area, it helps to understand how it works for me, because it helps me be able to understand how to reverse it. And that area right there, at the tip of my finger, that slot is open, as it is down here. I suspect that when the solenoid gets energized, the slider is going to come in and occupy the space with that piece of metal. Right there. When the solenoid is de-energized, the slider will fall back down, opening up that small area there, so that my ridge here is no longer it's no longer obstructed and will rotate. I suspect that this is how this works. So at this point, I've got the slider and the slider guard in place. The next thing to do, because I've got my spring captive with my temporary roll pin, the tip of the spring here needs to fish itself back into that hole right in the back. Right there at the tip of my finger. Right here it needs to poke through. Okay. So I'm going to take that tip of that spring and I'm going to put it back in that hole. And I can see from the backside that I'm seated in there. And now I've got the keeper just sitting loosely there, or the latch. Okay. Now at this point, I need to install my latch pin, and I'm going to want the top of my latch pin to be towards the top of the strike. And if you recall, the top of the strike has to have the wires coming up. And I'm going to insert this. I'm going to insert it down into the hole, and at the same time, I'm going to drive out my roller pin, my temporary roller pin. The issue is I've moved that slider a little bit, so I'm going to pull the latch out because I now need to reposition my slider because it moved, because I was lifting it. I've got it in position. I'm literally just simply going to place it on my desk without moving anything. I'm going to put my latch back in, feeding the spring back in. I'm going to take my roll pin from what would be the top of the strike and get it pushed in. My roll pin falls out. Now, here's the test. When I lift my strike, right hand orientation, this should be locked. It is. Here's the ultimate test. When I flip it over, it should be unlocked. And it is. Okay. So I have successfully reversed that. And all I did was reverse the slider. Is all I had to do. Take the slider from this orientation, flip it around the other way. Okay. The roll pin, I had said earlier when the gentleman said, I'm not sure why they include that. It is a temporary tool to keep the spring captive in the latch as you're reinstalling it. And if you're wise, when you push the latch pin down and through, when you push the roll pin to force the latch pin out, if you take the latch pin and bring it to the other end and stick it a little bit further, then it'll be right centered in where you need it, and you won't have to reassemble it. Okay, so at this point, we're in the up position. We're in the upside down position. Our latch pin is seated where we need it to be, that silver head. Now, the only thing left is to reinstall the solenoid. There's only one way it can go in the sense that the slider needs to fit inside of this area here, right in this area. The screw hole is here. The hole for the thread for the screw is in the back of that, so it could only go in this way. Okay. I'm going to put that down, and I kept my screws separate. I knew that the longer one was for the solenoid. Okay, we've got that captive. And again, locked, unlocked. And all I'm saying is locked and unlocked because, again, when the coil is energized, it's going to pull the slider up. You can see how it slides. Just that small amount of movement is what's going to keep that from work, is what's going to make it work. Locked. When the coil is energized, that comes up, allowing me to retract. I'm sorry, I've got it too high. It's locked. When the coil is energized, the slider comes up, allowing the latch to move. Great. So now the final thing is to put our box back on. You want to be very mindful to not shear the wires, crimp them, or otherwise compromise them. Okay. Why do the wires have to face up? It's because the slider needs to move towards the coil, towards the solenoid, in order for it to change the state of the operation. Right hand. And I have to tell you, we went through the entire video and I didn't recognize that the operation was incorrect. And what's funny is this has made me realize that the original installation, the first time I reversed this, it does seem to me that they sent the wrong hand. So I do need to speak to, my understanding is that the strike's going to be fail secure, and then you specify the hand. They might be coming from the approach that this is fail safe, and then you specify the hand. In that case, it would have been correct. But in my mind, the logic of specifying AC voltage would make you determine it is AC voltage would make you determine it's fail secure. Otherwise, you're constantly powered, constantly buzzing. That would not be what anyone would want. Anyway, now let's officially wrap up this video. And the important part of reversing the strike was that we discovered it was an error. We didn't send it to the client because the client's a homeowner, and What I'm inferring by that is the client doesn't make a living in the construction industry. That they do something else. I'm not sure what they do. They could be a lawyer or a doctor or a pizza delivery man or anything in between. They don't make a living rehanding electric strikes. They ordered it specified a certain way, and the obligation is the detailer, the estimator, the delivery truck driver, all of us in the chain of the role of distribution to get it correct. And we would never send that out knowingly incorrect, because it's just, that would be thoroughly improper. So we reversed it successfully. It is relatively easy. Perhaps at some point in the future I'll make a consolidated version of that video and say, this is how you do it. Put the instructions aside. And they're good. It's just you have to really look at the pictures in the installation instructions, and also, kind of use your in your mind's eye, apply your intelligence to say, okay, this is how it once worked. It would make sense if I want to reverse the operation. I'm going to reverse the locking plate or the slider. Anyway, we've got this wrapped up, and we're happy that we discovered the actual use. I had forgotten the use of that. And actually, the first time I reversed one of these, I didn't use the pin, and that's why I recall how difficult it was to get the spring in the keeper. I put the spring in loose and then tried to force the spring into position by using the latch to leverage it in place, and ultimately I got it to work. But now that I fully understand the role of the temporary roll pin, life is far easier. Anyway, there's a link below this video to the manufacturer's page where you can pull up not only all of the Trine products that we sell, but a link to the manufacturer's website, as well as a link to the full product catalog. I am partial to Trine, and it's because of that lovely customer service, technical support we got earlier. It is a mystery to me why it was sent out the way it was. In the future, I will be very clear to using plain language what I expect the operation to be on the strike when it ships. I would say, right-hand door with 24-volt AC operation, fail secure. And I would probably go so far as to even include a drawing of what I mean right hand. The only thing I can conclude is that they installed it as if it was DC, and with the argument that fail safe would be a typical installation. But it's a UL listed strike, so meaning you can use it on a fire door. So fail secure is how I would think the default. Because most strikes are indeed fail secure, I would think that the default ought to be fail secure in terms of an understanding. Or maybe I've done something wrong and I just don't yet realize it. But anyway, any questions on the Trine EN950, 24 VAC, 10B finish, or any other Trine product, please feel free to reach out to us. And thank you.